Mm, okay. Hi everyone. It's already noon here. I'm not sure what is the time in your time zone, but I'll start my presentation slides. Okay, today's talk is about inferred dimension members with inferred dimension members solution with MDS and SSIS. Before that, I'm Reza Rad, SQL Server MVP, author of SQL Server BI books, and Data Warehouse and BI architect and consultant, Microsoft certified trainer, and author of SSIS webcast series in Red Academy website, which there is a link at the end of this presentation to the tutorial videos. The agenda of speaking today is I will talk about inferred dimension member. What is inferred dimension member? 101 of inferred dimension member. And why we should be careful about that, why this is one of the challenges in the data warehouse and ETL design. Then I'll talk about what is the SSIS solution for doing inferred dimension member, and then we will bring the master data services as a repository to keep single version of truths and doing the data governance of that. Then I'll talk about the synchronization issue, which will happen when you integrate MDS and SSIS in terms of applying inferred dimension member. And at the end, I'll propose architecture with a demo of the solution to creating inferred dimension member and dealing with inferred dimension members with MDS and SSIS. If you have any question during this webinar, just send your questions through that questions text box, and I will get back them at the end. Okay, inferred dimension member 101. What is the inferred dimension member? If you consider loading facts and dimensions, in most of the cases you load a dimension table first and then fact table. This is the ETL kind of design scenario. So in most of the cases, the record of facts, which has the business key of the dimension member, will have that business key in the dimension. And so as a join, you will get the surrogate key of that dimension, and we will put that in the fact record. But there are sometimes that the business key in the source of the fact record is not in the dimension. We call that as an inferred dimension member. Because the only things that we have for that dimension member is just the business key. So all other attributes will be null, and in that case we will create that dimension member into the dimension, and we will assign a surrogate key to that, and then we will use that surrogate key in creating the fact record table. The reason is that if we don't do that, and if we don't create that dimension member, we may lose that record, and that record may just appear once in the data load. It may not be for every night, for example, in some scenarios. So for the yeah, I just go to second slide. Okay, so the solution is to create the record and set all attributes to null and create the surrogate key. There is an important consideration for that. Inferred dimension member should be updated after the first changes in the source of dimension. The reason is that the first occurrence was just the business key, so we hadn't any other attributes for that dimension. But the second occurrence and third occurrence, the second actually occurrence is when that record comes through the source of dimension. So that any change that happens there should be updated instead of applying kind of slowly changing dimension. I'll go to that slowly changing dimension a little bit further. So the steps, the ETL steps of doing that, we are going to talk about what's the best ETL scenario for doing this. So the ETL steps for that is that the inferred dimension member should be inserted into the dimension table at the time of loading fact table, before loading the fact record. Then the surrogate key of that inferred dimension member should be fetched and inserted in the fact record. then that inferred dimension member will be updated after the first appearance of that in the source of dimension, which is quite important. The important things of this is that we do not apply a slowly changing dimension for that. If you are not familiar with the slowly changing dimension, I just explained that the dimension attributes might change by the time, and we will do different kind of solutions for this change. If we want to keep that historical, if we want to just keep the latest updated value, we just do the update, which will be kind of a slowly changing dimension type 1. If we do not accept any changes in that attribute, like the birth date, or like the name, this not the name, like the birth date, like the father name, this might not be changed. So we say this is a slowly changing type 2. A slowly changing dimension type, sorry, that was type 0. The slowly changing dimension type 2 is talking about keeping historical information. So, for example, if I'm a customer in a city in USA, in Charlotte, and then I move to another city, let's say to Los Angeles. So we want to keep that historical information, so be able to actually slice and dice information by the geographical information of that customer. So it is quite important for some scenarios to keep that historical things. For doing that historical things, the way that we are doing a slowly changing dimension type 2 is to add a from date and to date to each record. One of the ways is way of doing that is this. So we will add a from date and to date, and by default all records has just a from date at the first, and with the to date as null or something big value. And when a change happens, we will put the to dates as the date of change, and we will create another record with same alternate key, with same customer number, but with different surrogate key, and with the new value, and all other columns will be the same as the previous number, with just the from date as the new date, and to date will be null. So every time that we want to get the latest one, we will get just the one that has to date as a null. So this is a discussion about the slowly changing dimension. I'm not going to talk about that in details because this is not the topic of discussion today. We are going to talk about the inferred dimension member. So the reason that I talked about the slowly changing dimension was that in the inferred dimension member update, we should be considered that the first change will not be a slowly changing dimension type 2, because the first change will be just adding some values to a dimension member that was not exist before. So this will be just a change. So SSIS solution for inferred dimension member. How SSIS actually can help in doing that inferred dimension member. So we had two steps, an insert and update. Insert happens in the time of fact load, and update happens in the time of dimension load. For the insert, we will use lookup transformation for finding the dimension member. If that dimension does not exist, so we will create that dimension member, which is actually the inferred dimension member with just the business key. All other attributes are null. If it is matched, if the dimension record is exists, then we just use that record, which is not inferred. And we also can set the inferred dimension member flag as an inferred as well. For the update, which happens at the time of the dimension load, we will use a combination of lookup and OLEDB transformation. And lookup is to just search for that dimension member, finding that dimension member. If dimension member is inferred, then we just update that record and we will remove that inferred member flag. If it does not exist, if it does exist but it's not inferred, it's a regular dimension record, we apply a CD, whichever it is, for example, a CD type 2, type 1, type 0, everything. And if it does not exist, we will create that new dimension. So this is the way of doing that in the SSIS. The good news is that SSIS has a specific component named slowly changing dimension component that do all this sort of things for the inferred dimensions member. there is only a problem with that component, and that is that this is a slow component. So if you want to work with that component is quite running heavily on the memory and CPU, and it's quite slow. But I just use that component here to just show you how this is going to work. You will understand the logic, and you can do all that sort of thing with OLEDB commands and lookup, transform, and that sort of thing. Because 1 hour session is not time to talk about all end-to-end lookup and OLEDB solution. But the slowly changing dimension would be good start for that. I'm showing you how that slowly changing dimension transform works in SSIS. Okay, I'm creating a new SSIS package. Before doing that, I'm just showing what we have here. There is a data warehouse here. I have a data warehouse with a customer dimension. That customer dimension has some attributes on it, customer information, and 2 attributes, which is from date and to date. These are because of that slowly changing dimension that I mentioned. I want to get some data out of another database, which is SourceDB. So I have a customer table here, which most of the columns are similar. So I want to load this customer information into that as a dimension. So we are in the step of loading dimension. So I just rename this as load dimension. In the load dimension, I'm using a data flow task. In that data flow task, I'm adding an OLEDB source, and I point that to the source DB and to the customer table there. So here you can see that sample customer records in this table. So here I can create an OLEDB destination, but considering that inferred dimension things to check if that exists, and if that exists, then do something. If it does not exist, and if it does exist, infer, do update, and that sort of thing. So instead of doing those things with OLEDB command and lookup, I'll use slowly changing dimension transformation. In the slowly changing dimension transformation, I point to my dimension, which is in the data warehouse. I choose customer dimension. Here in the slowly changing dimension wizard, I should say that what is my business key. These are a list of columns, and my business key is actually customer alternate key. Business key is the unique key for that source of dimension. So I choose that customer alternate key as a business key, and then here in the next step here I can choose that how I can apply that, how I want to actually apply that slowly changing dimension. I can say I want that to be fixed, I do not want any change, I want to change to be updated, or I want to change to be tracked with from and to date, which I want to show you this kind of things. So I'm just choosing one of the attributes, for example English education, and I'm saying that changing type of this is historical attribute, which is the type 2 of the slowly changing dimension. You should actually do this kind of things for all attributes in the dimension that you want to apply kind of slowly changing dimension, to choose which type of slowly changing dimension you want. But for this example, for the simplicity of this example, I just choose this. Okay, in the next step, I should say what kind of historical attributes I have in that dimension. Here in that dimension, I have from date and to date. So I choose from date, and I choose to date. So this from date and to date will be used for keeping historical information, and I use system start time to just get the time of this package. And here in this step, this is quite important. Here in this step, you see that this has an option to check Inferred Dimension Member support. So if I uncheck this, this will not check. This will not actually check existence of Inferred Dimension Member and updating and that sort of thing. But if I check, this will apply that thing. So this can apply Inferred Dimension Member based on a Boolean field in the dimension that says this is inferred or not, or checking values of columns to be null. I just choose the first one and next. After finishing this, the magic will happen and we will have actually all OLEDB commands, derived columns, and lookup and that sort of thing all actually done here. So we can just run the SSIS package and get this loaded into the dimension. I just first execute this and then I'll tag how this happened. Okay, when I execute this, it will start to get data out of that source, and it's just 1000 record. Let me just choose another source of data which has more record on it. I choose Adventure Works DW 2012. I think this is better. And I choose then customer. Okay, this one is better. Let me just truncate that destination table. Okay, as you can see, this will load everything and check slowly changing dimension for each attribute. If this is an existing attribute, if this is a new attribute, if this is a new attribute, it directly goes to the derived column that creates the from date, and then it inserts that to the destination. If it is an existing attribute, this might be inferred member attribute, which will be updated through an OLEDB command. This is actually running and finished. So if it is an existing inferred member, this will be updated through a command like this. So here you can see that this will update. If it is existing record but a change happened and it is historical changes, we will actually put a to date for the existing record and we'll create another record. So this is actually how this loading changing dimension component works. So loading dimension, it's just as simple as that, and we will load dimension like that. If we want to load fact table, it is again very simple. I'm just changing this to load fact. For loading fact table, I will just use a OLEDB source. I point that to my source DB. The sales is a source of my fact table which has customer alternate key. This customer alternate key will be replaced by customer surrogate key out of the lookup. Then I will use a lookup transformation to find out the corresponding customer alternate key. So I customer surrogate key. So I connect that to my dimension, which I'll load it right now. So the dim customer, and I create a relationship between customer alternate key of the source and in the dimension, and I pick the customer key here. After picking that customer key, I just insert that into the destination. I use match output because this already found there. So as a result, I loaded that into fact internet sales, which is already, and the customer key will be picked out of that lookup. Okay, so that's just easy. All of you already know that how to load that fact. I just execute that. Before executing that, I'm just removing one of the records in the table. That's for the inferred member testing. I'll show you that after doing this. Yeah. Okay, when I populate that fact table, you can see that all fact tables will be populated. If I just select, sorry, I have a, okay. If I just select the data from that fact table, you can see that this is already populated and the customer key left here. So this is a very simple execution of ETL execution, loading dimension and fact table. Right now we want to, if we want to add inferred dimension member insert in this scenario, the only things we need is to add execute SQL task or data flow task before that and get everything that is in the fact table, which that customer alternate key is not in the dimension, loaded into the dimension, and then do this. So it's just another step. So doing that inferred dimension member is just very easy in the SSIS. I'm not just doing this part because we don't have that much time. I'm just going to the second part and defining the problem after that to see how we are going to do that inferred dimension member with MDS. Okay, that was the demo. Then the master data services. In this example, we will try to keep customer data in the master data services as the single version of truth. Master data services is the data governance structure and master data management structure to keep the single version of truth of entity. For example, if we have customer dimension in a CRM, in a sales system, in different operational systems, we can keep that customer information in a central repository and applying central security things. All that systems will be subscribers of that master data services entity. And the business users, this is very handy for business users to go directly into that master data services entity, do their changes, and all other systems will do that changes because they are subscribers to this. If we are going to store that customer information records into the master data services as an entity, then we should consider ETL things to happen to get data out of MDS rather than getting data out of another system. So in this case, we will use MDS as a source of customer data. So when we use MDS as a source of data, we should have a way to get data out of MDS. MDS provides a way to exporting MDS data to another place, and this is happening with subscription views. Subscription views are the way that we export data out of MDS. And that subscription view is just as simple as a SQL view that you can use in the OLED video source. Let me show you how that's going to work. Okay, this is master data services interface. I'm not going to talk about this. This is completely separate sessions of talking. In that master data services, I have an entity here. That entity is similar to a table. So you can see that I have an entity for customers. So the same stuff are here. So I have all customer information here. And I want this to be used as the source of data. And as you can see in this UI, user can come here and do all kind of changes that they want and press OK to publish that change into the MDS. And all other systems like data warehouse, like sales, like CRM will be subscribers of this customer entity. So if I want to pick the customer entity information out of here and use that in my data warehouse, I go to the integration management, and in that integration management, in the create views tab, here I can create views based on that customer information or any kind of entities. I already have one. I just remove this one and create another one. So creating subscription views is just simple. I just name it as customers. I choose the model. Each number of entities are in a model. I have already my customer entity in this model. Then I choose a version. Versioning can be applied in master data services to keep different set of data. For example, if you want to apply versioning, that's a completely different area. I do not want to talk about that versioning. We don't have the time for that. And entity, I just choose the customer entity, and I say that I want all leaf members of that customer entity, which means all detailed record of that customer. And I just save it. When I save that, if I go to my MDS database, this MDS application works with the MDS database in SQL Server. In that MDS database in SQL Server, I cannot use tables. I cannot go and find customer table and use that as a source of my query, because as you can see, these tables generate automatically. And with any changes in that customer or any other entity, this will change as well, even the name, even the coding. So these are not reliable for data population. So that was why we created the view, the subscription view. After creating that view, you can see that there is a view here exactly with the same name that I've created with the MDM schema. So if I select records from that view, you can see that this is exactly the same information from the MDS. It has only just some some metadata columns, version name, unique identifier, version number, that sort of thing, code, and that sort of thing. And the real data is here. So if I want to use this as a source of data integration and data warehouse, what I have to do is just go back to load dimension, and instead of doing this, just connect it to MDS and write my MDS query here, or just choose the MDS view that I have created, which is customers. So that's, if I want to do that, I just create that. So that's just a matter of how I populate that from the MDS. But the story is not that much simple. When you create MDS, when you work with MDS and you want to work with SSIS and apply Inferred Dimension Member, there will be a synchronization issue. The issue is that Inferred Dimension Member happens during the fact load, so it's coming from the source of the fact table. So when you find that Inferred Dimension Member, if you load that, if you create that Inferred Dimension record into the data warehouse, but not in the MDS, then data warehouse and MDS will not be similar. So then the MDS will not be the single version of truth, because this is not the updated record. If the business users want to come and do some modification for the inferred record, he cannot, because that inferred record is not exist in the MDS. It does exist in the data warehouse. So that's the challenge, and what we should do to face that challenge and to solve that challenge is to actually create that inferred dimension member record in both data warehouse and MDS to keep them synchronized. So for architecture, for a solution, we should write back inferred dimension member into the MDS. It is very important that next dimension load should pick up same MDS record and change update scenario rather than doing a slowly changing dimension. And inferred dimension member in MDS should be flagged as inferred dimension member. The reason that we flag that is that this would be good for end user to just filter, for example, show me, if you want to just ask, show me those inferred members. I want to see inferred members and I want to add some data on it. For example, I want to say that this code is belonging to my customer with this name in this city and that sort of thing. So we should keep that stored somewhere, that this record in MDS is inferred. So for loading data back to the MDS, which is actually importing data into the MDS, we use another structure, which is a staging structure. MDS 2012 has a different staging architecture rather than 2008 R2, and this is entity-based staging, which means that there will be a staging table based on each entity in the master data services. So, for example, we have an entity for customers, so there will be a staging table for that customer. And the way that we import data into that MDS is to first load data into the staging table, then run a batch. That batch is actually a stored procedure with a similar name to that staging table to transfer data to the MDS. So before doing that, before continuing this, I just show you the staging structure of MDS. If I go here into the system administration of MDS, I can see list of entities, models, and all data structure that I've built. And in that data structure, for example, in my model, I have only a customer entity. If I edit that customer entity, here is the place that it says that that customer entity has a staging table which named customer. So what I can do is to go to master data services database, and I go to the tables. I'm scrolling down to table with STG schema, and I'm finding stg.customer underscore leaf. That underscore leaf will come at the end of this. So this is the staging table of the customer. And if I select this already has some records because I've done some testing here. But here you can see that except some metadata columns, all other columns are actually exactly columns of my MDS entity. So what I have to do is just to import data here with some metadata columns. The metadata column important stuff are import type. Import type 0 means that merge this into the existing MDS record if there is any. There are some other import types as well, but the 0 is the best one that we can use here. And there is also a batch ID and batch tag. Batch tag is a string that is helpful for us to distinguish that record. So the first step is to load data into that customer staging table. Then the second step for transferring that from staging into the main entity table is to run a stored procedure or run a batch. There is a stored procedure with name, if I be able to find that, yeah, under STG schema again, UDP underscore customer underscore leaf. If I run this stored procedure with some parameters like the batch tag, like logging options and like that sort of thing, then this will transfer data to that. If an error happened and something like that, then error code will be assigned something. So that's the way to import data into the MDS and actually write back inferred dimension member into the MDS. So right now I'm I want to talk about the solution to do the inferred dimension member with MDS and SSIS. So the solution architecture contains two separate parts, for insert and for update. Insert, as I've said previously, insert happening at the time of loading fact table. So we first look up for the dimension member. If that dimension member exists, we just use it because that's all. If that's not exist, so we should create a record in that staging table of the MDS, and we should set that this is an inferred. So for that reason, I actually created as inferred tag in master data services entity. So here we can see that there is as inferred flag here. So we will just create that record with as inferred. Then we will execute that batch and that procedure to transfer data into the MDS. We will transfer MDS record then into the data warehouse, and then finally we fetch that dimension Sargate key within a lookup and load that fact records with the new Sargate key. This is how we do the fact load, and for the loading dimension we should consider update. For the loading dimension we just use MDS subscription view as a source, and we check existence of the dimension member with lookup. If this is exists, if that dimension member is not exist and it's not inferred dimension member, just regularly insert it. If data warehouse not exist and this is an MDS inferred member, then just regular insert and set the inferred member flag, and just write back again to the MDS as well. If data warehouse exists and it is not inferred, so apply std changes because it is changed and historical stuff and that sort of thing. If data warehouse exists and it is inferred member and MDS changed, then we should update that record and remove that inferred flag. So this is the architecture. Now I'm showing how to do this architecture. So I'm just changing the load fact. So for that load fact, before starting that, I have to create a batch tag, like these tags that you can see. This is for essential for running the batch. So I can create a variable in SSIS. I named that as batch tag, string data type, and I use an expression task to assign a value. It can be a timestamped value, like the value that you see here, timestamp value with the entity name. So what I do, I just use an expression that I previously wrote. So I just use this expression. This expression just create a customer string with date and time out of it, and assign this to the batch tag. After assigning this to the batch tag, so I named this as generate batch tag. After that, I use a data flow task to import inferred record into STG of the MDS, into the staging, let's say. How can I do that? I use OLEDB source. In that OLEDB source, I select data from my source DB, select customer alternate key from dbo.sales group by customer alternate key. The reason that I do the group by is that if I do not do the group by and then I apply lookup on this, if I found multiple records, a single customer alternate key in multiple records that is not in the dimension, this will try to insert that multiple times. That's the problem with lookup with free cache. So I just get that, and then I just try to use a lookup to see is this exist in the dimension, which is customer, and I want to get the records that does not exist. So I say that give me records that is not match, and I'm joining this based on customer alternate key. If it does not match, then I want to import that into the staging table. Before importing that into the staging table, I want to set the import type of it. So I just use the derived column here. I want no match output, and in the derived column I say that okay, I want the batch tag to be there. I want to set import type, which we set this as 0, and I want to set is inferred to 1, because this is an inferred number. And then finally I load that into a OLEDB destination, which is here, into the, we are loading that into our staging table in MDS. So I'm just choosing the stage customer leaf. Okay, that's all. So that's for loading data into the staging. After that, we should execute the batch to transfer that. Execute batch, which will transfer staging to MDS. Executing batch is just as simple as running the stored procedure. So I just copy that. We just mentioned version name, log flag, batch tag, which is the important one. So I'm connecting this to the MDS, and I'm setting the source query here. So this will be the batch execution command. So after execution batch, we can import data into the, I just copy that one here. So we can import data into the data warehouse now. So for importing data to the data warehouse, again, we use similar source query to get customer alternate key. If that customer alternate key does not exist in the customer, in the customer table, then I'll just remove this and I'll create another lookup, because we created that record already in the master data services. So if that does not exist in the dimension, no match should go here, and here I just check existence of that in the master data services. So I'm just using customers view here. So I'm checking this with customer alternate key, and I'm getting MDS code. I named this as MDS key. This step is just for the fetching MDS key, which is quite important to track down. So I'm getting that MDS key, and then I can set a from date as well, so I use a derived column here, which output. So I'm saying the from date would be get date, and is inferred would be yes. And finally, I insert those information into the destination, which will be my customer damage with the MDS key as well. So the MDS key is inferred from date and customer alternate key. All other fields would be null. So, and after that, we will load the data flow task. Before doing that, I put all of this in a sequence container, and I connect my sequence container. So to the data flow task. So after doing that, I'm doing that data flow task. So this is so before running that, I'm populating that dimension records to have a set of all dimensions records before that. So this is for populating dimension record with the MDS. I'll talk about this part later. So first I'll just populating that dimension records. Just let me remove extra records here. Okay, I truncate them customer, I truncate fact table as well. So I populate the dimension first. This will populate some records of that dimension. I'll talk about this additional part a few minutes later. After populating this dimension records, we will go through that scenario of adding fact records. Before adding that fact records, I want to also add a record in that fact table which does not exist in the customer. So I'm going to the source DB, to the sales table, to the last record. I'm creating another record. With customer alternate key that does not exist there. Just something that okay. And I put order line here for 8407, order line number 2, 1, just 0, 0. Okay, so the date should be something 2013 12 sorry 13 12 2013 12 2013 12 product key. Did I miss the product key? Yep. Okay, so I just created a dummy record that's dimension populated at the moment. So here you can see that dimension has some records, but this alternate key does not exist in that dimension, and even in the master data services. So if I filter data here based on customer alternate key, and I just search for that, you can see that this is not in the dimension, not in the master data services, but that exists in the source sales record. Here it is. So now when I populate that fact table, okay, MDS. And let's change that MDS key to customer dimension. So I'm going back to that customer dimension, and I'm changing that MDS key to 200. Okay, that was that, so I'll run that again. Okay, I think there's not time to troubleshoot that. I'm just showing the other factor that I've done here. This is similar to that one. So we had same stage here, so creating the batch, loading into the staging, executing batch, loading to the data warehouse, and populating the fact table. I run this done. We don't have time to troubleshoot that one. So when I populate that one, you can see that a single record added to a staging table. That single record was the inferred member stuff, so that was added to in staging and also to the dimension and MDS, and finally all records loaded into the fact table. So if I go back to my dimension record, now I can see that dimension record here. This is the inferred record, and you can see that it is inferred flagged as 1. And it is pointing to an MDS key. That means that right now I have an MDS record here for that member. So I'm going to filter customer alternate key here, and here it is. So I have the record here populated in both MDS and data warehouse, and this is inferred. So the thing is, now if I do a change here, a little change here, for example, if I do change in English education, which we set to be as a historical things, for the first time I just expect this to be updated. So I set English education as BSc. So this got changes here. Now if I want to pick those changes into the dimension, I just run my dimension package, dimension load package. And this will pick that change as an inferred member update record. So you can see that this is coming through an update record of inferred member. If this is an inferred member update record, what we do is just update that inferred in the data warehouse and write back the changed, which is we will just like the is inferred as 0, and we will write back into the master data services. So this part is actually for writing back to the master data services for that record. And there is no new update in this running, so there is no historical thing, so it's just a matter of updating that record in the data warehouse because that's an inferred, and we are not applying historical changes and that sort of thing, and then export these things into the master data services as well. Okay, after this, right now I can go back to my dimension here. So again, I have a single record, so no historical things. I have English education updated, and this is not anymore an inferred record because this is already sourced from somewhere. And in MDS here, if I go back again, and if I filter that member, you can see that this is not inferred anymore here as well. So what happens if I change it again to something else, like for example if I change this to PhD or something. This time if I execute that dimension load, this time this will pick that as a historical changes. So you will see that this time the new record will, that record will come as here, not that side. So this is a record existing, it's not inferred, so we are setting an end date for the existing record, the to date actually, and we will create a record with from date, which from date is the date of this ETL run, and that will be the most current record. As you can see, this slowly changing dimension component is taking long. It's not that much good in terms of performance, but you got that idea to how to do these things with some derived columns, lookups, and OLEDB transformation. So after this change, I'll show you how that change applied. So we have that all of that populated into the switching dimension component, and that one record historically changed. So after this, I'm going back to here, and as you can see here, I have right now two records, which is right. The first record has to date because we had that record with BSc, and the second record, which is PhD, because we are applying a slowly changing dimension type 2, has the from date, not to date, and definitely it is not inferred. And in the MDS, we just have a single record for that, which is correct because MDS keeps the most current record there. So that was actually the solution for applying updates and insert. Benefits of this solution is that MDS would be the single version of truth, and there will be completely synchronized with your data warehouse. If you want to study more about this, there are some references about concepts like Inferred Dimension Member, slowly changing dimension. You can use Data Warehouse Toolkit, the book of Kimball, which is very good book. If you want some SSIS tutorials and MDS tutorials, you can follow the links here. Thank you. If you have any questions, I can go to these questions.
Thank you, Reza, for that session. That was really helpful. We're just waiting for questions now. If If anyone wants to ask Reza. No questions so far? Well, we're about 6 minutes past the hour, so thank you very much for your time, Reza, and attendees. I hope you enjoy the session, and as always, if you have any questions, you could ask us at passwbivc@secretpass.org or ask Reza himself in regards to the session. And other than that, hopefully I'll see you next time for the next session in December, which is, I think it's Thursday noon Pacific time, so I'll catch you there, or otherwise, yeah, have a happy holidays, and see you in the new year then. Thank you, Reza.
You're welcome. Thank you.
All right, bye.